This is Mrs. Hannaford. I'm going to take us through lesson 2. We have 3 learning objectives. They are as follows. We should be able to describe patterns of change. We should be looking at how a pattern is growing, and we're going to be determining a pattern's growth. So you should have your lesson 2 notes in front of you. So you've got 2 patterns right here, and those 2 patterns, I want you to study them. And then I want to know, how are the number of dots in each pattern changing? So this is a sample of what I noticed was changing, or that I noticed that each time I had 2 dots that were being added each time. I also noticed that I always have 2 rows of dots. And I want to explain what this means, the step number plus 1 more. So if I look at step 0, I have 1 dot. Then I'm going to notice for step 2, I have a dot and a dot. So step 1, 1 dot, and 1 more dot. Step 2, look what I do here. 2 rows related to the step number plus 1 more. Step 3, 3 dots, another row of 3 dots, and 1 more. That's what I mean by the step number plus 1 more. So step 0, I have no dots here. I just have the 1 more. All right, so that's what I noticed. Pattern number 2, how are the number of dots changing? Well, I noticed that we have different number of dots each time. 0, 1, 2, 3. I've got different number of dots. I go from 0 to 1 to 4 to 9. And then I also notice that I've got the same number of rows as my step number. Okay, interesting. Here are my rows. Step 3's got 3 rows. All right, so that's what I saw. So now moving on, it says, how would you find the number of dots in the 5th step in each pattern? So go ahead and jot your thoughts down on that. So pattern number 1, notice what I said. You could draw it. You can go back up and draw those dots. Or I could think about it. And what do I mean by that? Remember, 2 rows, always 2 rows. If I'm in my 5th step, I'm going to have my step number. So 5 dots in each row and 1 more dot. So 5 and 5 is 10 plus 1 more is 11. So that's how I would find the number of dots. Okay, let's look at pattern number 2. I could draw it again, or I could think it. 5 rows, 5 dots, 5 rows, 5 dots in each row, 25. That's how you could figure it out, any of those ways. Let's go ahead and turn the page to the next section. This next section is asking us to complete this table with the number of dots from each pattern. So I'd like you to go ahead and fill in for pattern number 1 and pattern number 2 for all of these step numbers all the way down to 10. And I'd like you, for the N, is to come up with a rule to describe how I could find any number of dots given any pattern number. So here are my amounts for pattern 1. And I come all the way down, and these I had done previously, and now I get to 10, and I have 21. How did I figure that out? Again, I'm going to use the rule that I had come up with, the number, the step number, and then plus 1 more. So I have 2 rows of 10 plus 1 more dot gave me 10 plus 10 is 20 plus 1 more is 21. Okay, so the other thing I want you to remember is, I always seem to remember we had this constant rate of adding 2. Okay, well that can help me determine my expression for my real number, or I can remember that I always took the step number, and I did it twice, and I always added one more. So 2n plus one more. 2n plus one more. So either way you did it, that was the rule that you would have written for the nth step. Okay, moving on now and looking at pattern number 2. Pattern number 2 says, okay, we filled all these in. We knew what 5 was. So now what about the 10? Well, I want you to remember that I did 10 rows, so 10 down, and 10 in each row. If I did 10 times 10 is 100. I could have done the same thing with the 5. 5 down, 5 across. 5 times 5, 25. So if I do that, n times n, and I'm going to simplify that down to be n squared. So that's my rule for the number of dots in the pattern number. So moving on, it says now what we're going to do is we are going to take all of our plots here, or our numbers, and we're going to plot them on the graphs below. So go ahead and graph pattern number 1 and pattern number 2 on the graph below. You can see that I went ahead and graphed pattern number 1, and I made a whole bunch of little tick marks here to help me line up my numbers better. So you could see that after I plotted these, that I drew a line through them all, and you're going to notice, oh, it looks like a straight line. Pattern number 2, I plotted in the same fashion. I ticked off all my markings, and I connected my dots, and I noticed that I have this curved line. So then on the next part, it says, okay, well, explain why the graphs of these two patterns look the way that they do. So I'd like you to take a moment and go ahead and jot down some thoughts as to why pattern 1 would have given us this and pattern 2 would have given us this one. So you can see that I jotted down some 3 explanations as to why the pattern for 1 looks the way that it does. I said that it was linear. How did I know it was linear? Because it has a constant rate of change. What do I mean by that? That means every time I'm adding 2 to the previous number or to the next number. So 1 plus 2 more is 3. 3 plus 2 is 5. 5 plus 7. 5 plus 2 is 7. 7 plus 2 is 9. That gets me to the next point on the graph. Also, that I added the same number of dots each time, which was that plus 2. So again, linear, constant rate of change. I could even see it right here in my my rule of 2n plus 1. That 2 is my rate of change. Looking at pattern number 2, what did I notice? I noticed that it was curved, most definitely. Kind of reminds me of Unit 5 that we just finished. The other thing is, I'm going to assume that it's got an exponent, or I know that it's got an exponent, and I'll show you what I mean by that in just a minute. And the number of dots is increasing from step to step. So take a look right here. This is increasing. I'm going from 0 to 1, 1 to 4, 4 to 9. What did I go? I went up 1, then 3, then 5, then 7. And when I wrote my rule, notice that I've got an exponent right there. So that exponent is always 2. I noticed that it was 2. Okay, so, which gave me this curved line. So now let's go ahead and move on to the next page. So I'll meet you there. So in this part of the lesson, we are now looking at expressing a growth pattern. So what I'd like you to do on your own is I'd like you to take a look at this pattern. I want you to notice about the pattern of squares. What is going on? How are you noticing that it is growing? What do you notice about this pattern that you can jot down? Then I'd like you to answer the question of, is the number of small squares growing linearly? How do you know? And then after you answer that question, I'd like you to go ahead and complete this table that includes coming up with a rule for n. So go ahead and do that right now. So I noticed three things in this growth pattern, and I shaded them. I noticed that in the middle of each pattern, I have this square, and that's shaded in maroon. And I noticed that there is this relationship between the step number and the size of the square. So 1 by 1, 2 by 2, 3 by 3, okay? And also, I always seem to have two more in addition to my square. 1 by 1 plus 2, 2 by 2 plus 2, 3 by 3 plus 2. And I also seem to have the same step number as the number of rows. 1 row, 2 rows, 3 rows. To go on and answer the question of, is the number of small squares growing linearly? So I'm going to look at that and go, well, no, it's not, because it's not growing at the same rate. I'm going from 3 squares to 6 to 11. That's not the same amount each time. It also asked me to go ahead and complete the table. So what I did was I went down and I completed the table based on what I knew. And then it asked me to do 12. And you'll notice here that how did I get 10? Well, I know that I had a 10 by 10 square plus 2 more. A 5 by 5 square plus 2 more. 12 by 12 square plus 2 more gives me 146. So go ahead and jot that down, and then we'll come back and we'll answer the very last question, which is the number of small squares growing exponentially? Explain how you know. So I want to go back and just, in case some of you missed this. So this 10 by 10 plus 2 more, 12 by 12 plus 2 more, goes back to the step number 3 by 3 plus 2 more. So that's where I got that. And I really want you to hone in on this square idea. So then that's where I got this n squared, because it's n times n, which is going to be my step number, plus 2 more squares at the end. So n squared plus 2. So then it says, is the number of squares growing exponentially? Well, I'm hoping that you answered no, that it's not growing exponentially. And how do we know? Well, we know that it's not growing at a constant factor, meaning this isn't, I'm not multiplying 3 by something to get to 6, 6 by the same something to get to 11. It doesn't work, nor am I adding. So what is going on with this growth? Well, that's what we're going to be looking at in the next video, but it is not growing exponentially, okay? So next video is all about putting it all together.